Hi, my name is Pranav Annapareddy, and today I'll be talking about my research on cybersecurity and software engineering. And with modern software becoming more complex, cybersecurity can't just be an afterthought anymore. It needs to be integrated earlier into the development lifecycle, and that's exactly what this project explores. So the core focus here is on application level threats like phishing, insecure access controls, and tainted data propagation. And these issues can lead to serious exploits like SQL injection if they aren't caught early. And all of this aligns with chapter 12 of Somerville's textbook, which emphasizes that building secure systems, it's not just about patching vulnerabilities after deployment, but you have to design defensively from the start. And if you look at the image shown in the diagram, or if you look at the image shown in this section, it's basically a diagram showing a simplified flow of how tainted object propagation analysis works. So Java bytecode and vulnerability specifications in PQL are given to an analysis engine, which basically traces insecure data flows. And when these vulnerabilities are found, their warnings are sent to the IDE, which would be Eclipse in this case, so that developers can catch and fix these issues before deployment. So I chose to focus on secure coding principles and static analysis instead of and excluded network and hardware level defenses because I wanted to keep this targeted and practical. So for the research side, I pulled from three peer-reviewed sources. And the first article it showed how static analysis tools help uncover security flaws in Java applications, and another explored secure software deployment in small businesses, and the third compared to software development lifecycle models and how they support or limit security efforts. And each one reinforces the same key message, which is that early integration of security makes a huge difference. Okay, so here's where gets interesting. So even though all these security tools are available, a lot of teams don't actually use them well, or they wait until the very end of a project to think about security, and it's a big risk. It's waiting until the final exam to study. So the image you see here is a PQL query. It's a search tool that checks how unsafe data moves through a program, and it looks at not just the direct assignments, but also data passed through other variables. And this helps us catch hidden security issues early before they cause problems. And so if teams actually want to improve, so this section of the infographic explores that early tool integration and consistent education are the biggest drivers of secure development. So look at this chart, for example. It shows real applications that were analyzed with static analysis. And some of these projects had over 50,000 lines of code and hundreds of classes. And the takeaway from this is that static analysis isn't just for small projects. It can be scaled for even the large massive projects, and it still works. So one thing I found especially interesting for in this project was that how structured development models help with security. So for example, this V model diagram shows how every development phase is matched with a test phase. So for example, while developers are working on architecture design, testers are already preparing integration tests, and that structure makes it easy to embed security validation from the beginning and not just during final testing. It's way more effective, and it shifts the mindset from reactive to preventative. And it's also, as I mentioned earlier, it's great how these frameworks, the tools and frameworks, they already exist, and it's just a matter of prioritizing them. So to wrap things up, building secure software isn't just about plugging holes. It's basically about designing code and processes so that these vulnerabilities, these holes never show up in the first place. So with the right tools, solid practices, and a preventative mindset, developers can make software that's both functional and secure. And thank you so much for watching. I've included all the references at the bottom of the infographic, so feel free to check those out if you want to dive deeper. Thank you.